Hello everyone. The problems that we try to deal with and the application of the techniques of this course have a few things that make it very appealing to me. One of those things we already mentioned in the introductory video in week 1, namely the combination of quite predictable technology and very unpredictable human behavior. This combination gives problem situations with fundamental uncertainty. The presence of people is appealing for several reasons. Not only does every actor have his own perception on the problem and also his own idea about what should be done to solve it, but these ideas and opinions of people also tend to change over time. This dynamic characteristic increases the complexity even further. Also, this is fundamental uncertainty. Dealing with this source of uncertainty by using scenarios might not bring us very much further. Another way of dealing with this source of uncertainty, although for a very specific part of the problem, namely the financial part, is to use net present value. For financial criteria and uncertain situations, it is possible to translate the future numerical values of these criteria into a comparable numerical value for today. Imagine that you have the opportunity to either receive 100 euros today or in 10 years' time from now. What would you do? Most likely, you would prefer having the 100 euros today, rather than in 10 years. And for good reasons. You have no idea about the world in 10 years from now. Will you still be there? Or have you been run over by a bus? Well, a little less dramatic. You have a clear idea of what you can do with this 100 euros today, but no idea what you can do with it in 10 years from now. And think about the interest rates too. If you would put the 100 euro on a bank account, you would receive interest each year, which can become a substantial amount over 10 years, at least if your bank does not go bankrupt. You have to make a decision in which finance plays a role, and most likely many of your decisions will be like that. You have a hard time. Your project might run for many years. You have to invest now, you have to buy machines now, to develop technology and hire people. And eventually you hope to have some income with your project. You hope to sell it to customers, or that people will use it, get access or pay you royalties. But there is a substantial amount of uncertainty. Will the project be a success? Can the technology be developed? And if the project is finally there, will people use it? And if people do use it, what will they pay for it? And what is the amount of money worth in, for instance, 8 years from now? How do you compare this amount with the amount of money you spend today as investment? It's all in euros, dollars or yens. But 1 euro today is not worth the same as 1 euro 8 years from now. The same amount, but also different. There are all kinds of reasons for this. Psychological, we already mentioned them, but also something such as simple as interest when you put your money on a bank account. And you also don't know if your customers are going to pay you in 8 years. Still, today you have to make the decision to either go for the project or not. Net present value calculation is something you can use here. In your book, in chapter 5, it is explained in detail. In this video we focus on the reasons why using the net present value might be very useful. And we also want to warn you for some very common mistakes.
When using NPV, you have to choose a function to devalue the amount of money over time. You can read that in your book. There's an R factor in this function. This R factor represents a few things. Interest you would receive when putting your money on a bank account, and uncertainty present in your project. To estimate the value for R, for the interest part is quite easy. What do you receive if you put your money on a bank account? It changes over time, true, but roughly 4 to 5% per year on average is not such a best estimate. It is more difficult to estimate the percentage for all the uncertainty in your project. We suggest you to take a few areas of uncertainty that are present in your project. For instance, technical uncertainty, if you have to develop new technology, or geographical, for instance, when your project takes place in an area with active volcanoes. There are different kinds of uncertainties that influence the project, and they all add to the financial risk. More and larger uncertainties give more risk. You represent this higher risk by a higher value for R. The classical mistake is that people identify a lot of these areas of uncertainty in their project and estimate a small percentage for each of them, when you end up with a high values for R of 20% or higher. This is extremely high. Your project must be very uncertain to devalue 20% of the finances every year. As you probably do not yet have a good feeling for order of this magnitude of these R values, here is an indication. Projects that are quite certain roughly are between 4 and 6%. Uncertain projects between 8 and 12%, and very uncertain ones between 12 and 15%. If you want to have R values above 20%, then probably operating a manned base on Mars is a good project for you. Now study the NPV in chapter 5 from your book and use the NPV in your case. Take 2 alternatives and a financial criterion. Design an NPV, make your calculations and draw a conclusion. If the NPV is very negative, do you always have to turn down the project, or is that something you cannot say yet?